So thank you for coming and welcome. I'm Piero Oddone. I'm the director of FERMILAB. And we are very much looking forward to this evening's discussion on extreme research. This event is part of a joint speaker series that was developed by the University of Chicago, Argonne and Fermilab. And the purpose of the series is to give faculty, researchers, scientists, and engineers from all three institutions the opportunity to meet and converse over interesting topics with good food and refreshments, that's the most important part, to help fuel the discussion. Ultimately, we hope this series will help spark connections and ideas that might one day lead to new research collaborations among our institutions. Before we get started, I would like to recognize Don Levy, Vice President for Research for the National Laboratories, and Eric Isaacs, Director of Argonne, who together with me are sponsors of tonight's event. Unfortunately, Eric cannot be here tonight. I also like to recognize Yankee Kim, Deputy Director here at our laboratory, and members of the Office of Communication, members of the Joint Planning Committee, and the University Special Events Office that has helped organize this event tonight. At this time, I would like to introduce the moderator of tonight's panel discussion, WBEZ reporter Gabriel Spitzer. Gabriel covers science, health, and environment for WBEZ. He's the creator and host of Clever Apes, a nano-sized show about Chicago's rich scientific community, its quirky characters, and the mind-bending questions they are out to answer. Gabriel's hosted WBEZ flagship news magazine, 848, for a year. He hosted live special coverage of President Barack Obama's election and former Governor Rod Blagevovich's impeachment.
Soup to nuts.
Before coming to Chicago, Gabriel worked on public radio in Alaska, where he hosted the award-winning weekly magazine show AK. There's not an AK-47, I don't know what it is.
No. For Alaska. But that's a good question.
He has contributed regularly to national programs, including Morning Edition, All Things Considered, Marketplace, and Living on Earth, things that I listen to on the radio. His work has been honored with awards from the American Association for the Advancements of Science, the Association of Healthcare Journalists, the National Association of Black Journalists, and Public Radio News Directors Incorporated, among others. He lives in Chicago with his wife, Ashley Gross, and his sons, Ezra and Oliver. Before Gabriel introduces our panelists, we've asked him to say a few words about tonight's theme, extreme research, interesting places, and unusual challenges. Please give a warm welcome to Gabriel.
I have just a few things to say, and then I would really like to get right into our panel. Thank you all for coming out tonight. This is a fantastic place to be, and I love the disco ball, and I was thrilled to discover its provenance from the middle of a bubble chamber detector. If that's unless Craig was pulling my leg. So in any case, it's great to see you all, and a lot of people. Get out of here, fly. I have spoken to you on the phone for stories and stuff like that. And now I get a chance to see you in person. That's a real thrill. So you know, it works both ways. You don't know what I look like, but I often don't know what you look like either. No, it couldn't be better. Believe me. Are you? I'm glad that I'm up on a platform here because I'm told that my voice is taller than my body. I have, I think, what is a really interesting job because I get to meet so many people like folks who are in this room who I admire so greatly and get to dabble in sort of the kind of work that you all do. But of course, my sort of experience with extreme research. By the way, can we all agree that whenever we use that term, we have to play air guitar just a little? You know, it's much more limited. But as Pierre mentioned, I came to Chicago from Alaska. I was there for about 3 years working in public radio there. And so I have a little bit of experience of kind of extreme environments and doing my own kind of journalistic research in those setups, which have given me, I think, a few insights into the kind of things that people deal with here. I was there in Anchorage, which is, you know, kind of a medium-sized city, a not that interesting city in and of itself. But I was lucky enough to get to go to these bush villages quite a bit. And these are villages that are flung, you know, in some cases 1,000 miles from the nearest road that is connected to other things. So a lot of these places you have to fly into on tiny little bush planes, or some months of the year you can take a boat to, and they're extremely isolated from other villages and from sort of mainstream North American culture. And that was a really interesting place to do journalism and to do science journalism. And maybe the most extreme thing that I can remember from my time in Alaska would be the most mundane thing for somebody who actually lives in one of these places. But I was going to this village called Kivalina, which is a little village in the Arctic in northwest Alaska on the coast. And you know, you take like 4 planes to get there, and you finally get there. You land on a gravel airstrip in the middle of nothing. It was winter, so of course everything was covered in snow and ice, and it's like 1.5 miles from the village. And so you have to get there with your stuff. You have to get there. So I was told somebody will pick you up on a snowmobile, and take you into the village. And so I got off the plane, and everybody sort of disappears, and then the only person left is this little old woman who must have been 80 years old. She was about this big, and she's like, "Okay, come on." And so she gestured for me to get on the back of her snowmobile. Okay, great. So I got on there. I was sort of green at that time. I hadn't been in Alaska a long time. I hadn't ridden on a lot of snowmobiles. I didn't really know what to expect. And this is on the coast, so it's all dunes. It's like ski moguls covered in snow. And she got behind the wheel, and she gunned that thing, man. We just hauled over these things, up, down, up, down. I was sure I was going to fly off. I didn't know what to hold on to, because I didn't want to hold on to her. I was sure I would break her. She was so tiny. There was no handles or anything, so I held on for dear life by pinching the vinyl of the seat that I was sitting on with my thumb and forefinger, and just gritted my teeth, and I was sure that I was going to get sucked under the tracks and get chewed up by this snowmobile. And somehow I didn't, as most people don't, it turns out. But you know, there's a lot of sort of ordinary things for people who live in this region that for a city slicker like me were quite extreme. And I'll give another example. There was another village that I went to for about 3 or 4 weeks called Shishmaref, which is in the same region, also a coastal village right near the Arctic Circle. And I went there to do an audio documentary because Shishmaref is sort of on the front lines of climate change. And what's happening there is that it's on a barrier island that is made really of nothing but sand and permafrost. And it used to be that the sea ice would form in, say, September. The sea would freeze. But now the sea ice is forming later and later as the climate warms. And of course, the climate is warming faster in the Arctic than it is just about anywhere else. And so now the sea ice forms late in the fall. So in, let's say, October, these big fall storms roll in. And what happens is it sends the waves into the bluffs that on the edge of this island. It undermines the permafrost. The bluffs fall away, and the island is basically melting into the ocean. And this village that's been there for at least 1,000 years is disappearing. So I went out there to sort of capture the experience of these people as they kind of watch their ancestral home dissolve. And I went out there with this morally compromised journalistic thing where we really hope something bad doesn't happen, but if it does, we want to be there. And so I went there in October and saying, look, if there's a storm, that's what I'm after. I'm after a storm. Who am I kidding? And I got there and sort of was all focused on this, whether this extreme event was going to happen on my watch. And I got there, and the weather was lovely for a while, and there was nothing to really report on except for the culture of this place, which was also part of the story. And I spent my time trying to get to know people, get myself invited over to people's houses, understand this is an Inupiaq Eskimo culture, 98% Alaska Native people. And I discovered that there's a real barrier, cultural barrier, and a real mistrust between Alaska Native people and white folks who come from Anchorage. And I sort of knew about that, but I thought, well, surely they'll know I'm okay. But it was difficult. And this is actually a place that's reputed to be very friendly to outsiders. But I found people were very friendly to me when they ran into me in the stores, when I would run into them out and about. But then I would make an appointment with somebody, and they'd say, oh, sure, come by tomorrow around noon. And I'd go there, and they wouldn't be there. And I'd see them later, and I'd say, oh, hey, sorry, I missed you. Maybe we can reschedule. Oh, yeah, come on to tomorrow around 2. And I'd come at 2, and they wouldn't be there. And I generally discovered, like, these folks don't have any good reason to believe that I have their best interests at heart. They, for pretty good reasons, based on history and other things, I'm bringing with me the baggage of many generations of mistrust, miscommunication, etc. And so I discovered that my main project really, in this extreme circumstance, was to forge a connection between myself and these people so that they would open up to me. And painstakingly, working really from morning to night for weeks, that's what I did. And I went on hunting trips with them, I played bingo with them, I did all this stuff. And gradually, people began to open up and warm up to me a little bit. And then, the last week I was there, I had had breakfast at this guy's house, who was one of the village elders, and we were eating sourdough pancakes. And I started to hear the wind kicking up outside. And I didn't really think much of it, and they didn't bat an eye. And so I was sort of in there having a good old time. And then this was about, I think it was 2 or 3 days before I was due to leave. And finally, when I walked out, I saw that the wind was actually like really whipping up. And people were kind of gathered on the shoreline. And I was wondering what was going on. And I went over there, and I saw there was this one bluff that I had my eye on, because I knew that it was dicey. And I saw that it was about to collapse because the waves were coming up. And the winds continued to kick up until they were gusting to like 50, 60 miles an hour. And all of a sudden, the storm was upon us. And so I turned on my tape recorder, and I'm going to play just a little bit of audio from it for you now. I think it's only about 2 minutes long, so bear with me. This is, oh, look at that. I think you've got it. It's slide number 42. We'll have a listen.
October 19th. Winds have begun gusting to 60 miles an hour. People are hauling boats in and moving their meat drying racks. Shishmaref is bracing for another fall storm. I watch the waves devour the beach and begin pounding the bluffs, cutting deep into the bays. Then, one by one, the bluff faces slide off in whole sheets.
Just eating it, you see that? Just throwing stuff.
People with a job to do, like village police officer Dennis Davis, spring into action.
You see that tank farm back there? Huh? You see that tank farm back here? It's starting to eat that away pretty good. Might have to ask your dad to put something down there or something.
He's already trying to take care of the blue school.
The blue school?
That thing's real bad right now. Even that telephone pole fell down.
So anyway, that's just a little taste. I mainly played that because I love I mean, I don't love it, but the splash that you hear, because I stood there and I stalked that bluff for like 45 minutes with my microphone, waiting for it to fall, because I wanted to get the sound of global warming, and that is the best that I could do in doing that. But anyway, so the lessons that came out of this for me were really that I'm actually very, in my morally compromised journalistic way, very lucky that this happened to me at the end of my trip, because of the legwork that I did in trying to get people to trust me. And so because I was able to forge those relationships, when the time came, people talked to me when they were in the middle of extremely stressful situations, people evacuating houses that were about to fall into the ocean, people who were desperately trying to save public buildings, who had existential anxiety about this place that they were so deeply connected to, and yet they were willing to talk to me, this white guy from 1,000 miles away, because I had sort of been lucky enough to have been forced to make them believe that I have integrity and that I care about what happens to their village and so on. So it's just, it's a different world, obviously, than what a lot of the scientists here work in, but I feel like it has a few lessons about the complexities of working far away from the comfort of a studio or a laboratory, and the intertwining problems that present themselves in dealing with kind of the logistics, the human interactions, and then just the sheer natural obstacles that get thrown in your way in these extreme environments. So I want to show you just one little picture, well, maybe two. If you would put up slide 43, I'll just give you a sense of what this looks like. You can sort of see that this was a straight line before, and you can see that a big bite has been taken out of the coastline there. And if you look at where that guy in blue is standing, you probably shouldn't be standing there. Because down at the bottom there, you can see how the bluff has been undermined there. The permafrost has just been eaten away. And that just happens inexorably, because this island is made of nothing but that stuff. And so, undermined, and it just falls away. And it's really heartbreaking. And it's only gotten worse since then. In fact, we just had this giant storm in Alaska. I don't know if some of you know about this, a week or so ago, a week and a half ago. Luckily, it came at an angle that wasn't disastrous for them, but more erosion year after year after year in this village. So anyway, that was my experience in Alaska. And before we move on, I'll just say that fly that was bothering me before, I got him. Right in there. I think he died happy. So with that, I'd like to turn it over to our panel of diverse and really interesting people. Before we begin, I do want to say that Elizabeth Lonsdorf, who you saw in that video, who was scheduled to be joining us, unfortunately is not able to make it tonight. Something came up at the last minute, and she sends her sincere regrets. But her work is fantastically interesting. I've done a story or two that involves her chimps, and so she's worth looking up on your own time. But I'm just going to introduce the folks here. We're going to get into a little, I'm going to ask them each to kind of talk a little bit of, give a thumbnail of the work that they do, and then we'll kind of open it up to some of the bigger questions here. So right here to my right is Albert Coleman. He's an assistant professor of geophysical scientists at the University of Chicago. Next to him is Forrest JEHLIK, research engineer in the Center for Transportation Research at Argonne. Gina RAMEIKA is next to him. She's a physicist in the particle physics division at FERMILAB, working in the neutrino universe. And Doug Sisterson, the research meteorologist in computing, environment, and life sciences at Argonne. Thank you guys all for being with us tonight. So, Albert, why don't we start with you since you're here? And maybe you could just give a little overview of the kind of work that you do, what puts you in these extreme environments, and then we can talk a little bit more about that.
Sure. So most of my research has to do with trying to understand how atmospheric and oceanic composition have changed through time and what controls these changes or stabilizes certain states. And when I say through time, that can mean looking at trying to understand the modern, can mean trying to look to understand glacial, interglacial variations, or a lot of my attention right now is trying to understand what controlled climate and atmospheric composition back in the Archean some 2.5 billion years ago, or a little bit before. And it's really that last piece of work that has taken me to Kamchatka, Russia, which I guess is what landed me in this seat tonight. Where in many cases, what I do is I try to identify important processes, usually, especially the deeper back in time we go, usually microbially driven processes where I think that they are what we need to understand in order to piece together how chemical fluxes, biogeochemical fluxes worked long ago. And in this case, I'm looking at carbon monoxide cycling in hot spring environments, and now kind of moving more broadly to just general anaerobic environments. This was something that I began in 2005. It was an opportunity for me as a geochemist at the time to learn some environmental microbiology and molecular biology, and I think I got hooked on it at the time. I'm happy to talk more, but I want to. Yeah. So, right, there was, I think Discovery Magazine at one point published a list of the 10 worst jobs in the world, and I think it was in the top 5 was extremophile excavator. So they gave it, and I can give you many reasons why they had some of it right, but most of it wrong.
Well, wait, let's talk about that. Each of you, we're gonna have a little mini conversation before we move on to the next person. So, what are the things about it that an average layperson would say? Why the hell would you want to do that?
Right. Well. How many different ones? I mean, it really depends on where you go, but most of the environments we study for hot springs are in volcanic environments. They're remote environments, they're fairly undeveloped, and in our case, I mean, what pictures to show here? Well, our companions in the field, for example, if you could show slide 9, this was something that I hadn't fully anticipated what it would mean to be doing work in a remote environment. But in the lab, you might have a picture like this on a calendar that's in your office, for example. And then you go into the field in a remote environment, and then this is a daily occurrence. And that bear may look big. That's a moderately sized grizzly or brown bear. But they get bigger, and they get closer than that. And often you would think they'd make more noise as they're traversing through the blueberry patches that line this particular site, Uzone Caldera in Kamchatka, Russia. But they're actually pretty quiet. Their eyesight is very poor. Their sense of smell is good, but that doesn't help or hurt, I suppose, if depending on which direction the wind is blowing. I'm sure they've smelled me. I've never smelled them. We wish to study microbes, and the geochemistry of these hot springs will be very focused. We'll have a group of 3 people perhaps at a spring, 2 people studying, 1 person on bear watch.
You have like a PhD biologist on bear watch?
We rotate through.
Okay.
At first, you don't trust someone without proper training to keep their eyes open for these companions of ours. And in fact, there was one point when there was just 2 of us. We didn't have anybody on bear watch. I was with a graduate student of mine, and it was midway through our field season, and the field season was being followed immediately by a workshop in the one city that is on the Kamchatka Peninsula. And I was trying to remember which day my talk was in this meeting. And so I was asking him, do you remember, is it first day back or second day back? Because that influences whether I have to worry about getting my talk ready right now. And he said, second day back. I said, good, that's what I thought. And you know, it doesn't really matter that much. At least it's not a life or death situation. We're in this little ravine sampling some springs. Look up, and there's a bear about 15 yards away from us eating the blueberries. And we're removed from our backpacks. We do go in there with protection. We carry flares, which are not your average roadside flare. They actually send a flame out. They don't shoot a flame, but it's like a jet of red that's very loud and goes out that far. And the idea is that it might scare or at least amuse the bear for enough time.
It sounds like a lightsaber.
Yes. Except, well, I'm not going to try to imitate the noise, but it's a little bit louder than a lightsaber, and probably a lot less effective. You might be better off using the Force.
Maybe so.
But it gives us this confidence that we can be out there and be safe. And so, you know, I see the bear. I start edging towards the backpack to pick up the flare. The backpack is closer to the bear. Get the flare. Now I feel confident. Now I start yelling at the bear to go away. And the bear looks up at that point, looks at me, goes back to eating blueberries. All right, so I've had that work before, but it didn't work this time. And I thought, all right, what are my options here? And there are some birch trees close by. They look like just the right size, about that big around. I think my student can climb them. I can climb them. I'm not sure the bear can climb nor knock them down. So we talk over our strategy. We get everything settled in about 30 seconds for what we do if charged. And then the bear is still eating blueberries, not moving, and we're standing there, and we're thinking, you know, this is actually really peaceful. And so, you know, we watched the bear for a while, and then when it left, we continued with our work, shaking a little bit, which isn't good for the microelectrode work we do, but otherwise things went well.
Another day at the office.
Yeah, yeah. So that's one taste of things that I hadn't expected that some might consider an unpleasant side of the work we do.
But it sounds exciting at least, right? And you have to sort of be looking out for, so you're looking out for things coming at you on the tundra like bears, coming from the sky like weather, coming from the ground because you at any time could step in boiling mud.
Yeah, right.
Right?
Yeah, so the big things are helicopters, bears, and punching through the ground or the crust that we walk on. And so we wear these waders they're thigh waders. The idea is that if you had boots that went knee-high, they probably wouldn't be deep enough and they would just kind of incubate your foot in really hot water, which is not what we want. So there are 2 schools of thought. Either you go with sneakers or you go with boots that come up to here. And I prefer the high boots that have extra insulation in them.
There must be somebody in your field who goes out there in like sandals or something like that, right? I feel like every field has got the one guy who's like, oh, I don't need to wear gloves.
So we do work in Lassen Volcanic National Park, and I don't know if anyone's been there, but there's one particular geothermal field there that's called Bum Pass Hell. And it's kind of a weird name, and you could make jokes about it in a lot of ways, but it's actually named after a person whose last name was Bum Pass, who was the original person who explored that site. Well, I should say the original person of European descent who explored that site. And he actually lost his leg at one point because he went through in the spring. And so it does happen. You hear reports of it, and that's why you take proper precautions. And even then, you try to be careful. But there was one time I was trying to take a photo on what I thought was nice, solid, kind of cindery gravel, and to frame it properly, I just needed one step back. And so I took that one step back, and my foot started sinking slowly and slowly, leaning forward, trying to get my foot out and pull boot out. And it took me about a minute to get out, and when I got out, my footprint, which was pretty deep at that point, was bubbling. And it was, again, one of those situations where you realize this is why we try to be so cautious, and even then, we're not cautious enough always. So
that's probably something that could apply to a lot of what you, the people at the table here do. Well, thanks, Albert. So we'll get back to everybody in due course, but for now, I'll talk to Forrest JEHLIK a little bit. Maybe you could just give us a little overview of your work as well.
Okay, so I work in the Advanced Transportation Research Center, Argonne National Lab, and we take a look at advanced vehicle technologies. And a lot of our funding comes from the Department of Energy, and our main goal, as most people here probably do know, is to reduce our reliance upon imported petroleum. It's a big issue. And so we'll look at anything from advanced vehicle technologies, whether it's electrification, plug-in hybrids, alternative fuels, whatever, and then try to advance these technologies and use it kind of as an outreach to build that market. And so one of my duties, amongst many, and just the one I'll focus on tonight, is a green racing program we started a couple years ago. And so the goal of the green racing program is that when you take a look at the cycle time for race cars in a series, I mean, they have these races they have to get to in this time, and there's no such thing as missing a deadline. You miss a deadline, you don't get on the starting line, you don't go, you don't race. And so it's a perfect opportunity in a situation where the cars are thoroughly abused to advance these technologies and prove them out, and then hopefully use that as a springboard to not only outreach the community that goes there and is passionate about racing, but also a perfect grounds to test the technologies and make sure it's durable enough to go into that. And so tonight in particular, I'll talk about some of the work I've done with this Project Green Camaro. It's a more advanced engine renewable fueled car that we've actually put on exhaust after treatment and did a bunch of really precise measurements to determine how we could basically take racing today, remove it from the environmental debate, and actually make a car that would be on some levels as clean as like a small 4-cylinder sedan driving around town today, and then show the potential of that in the market. And so that's what I'll talk about tonight.
Very cool.
A lot of good stories about that.
Well, let me ask you a couple of things about the work there. I mean, for one thing, I was wondering if there's a kind of culture clash between the science and the racing world, because I thought, well, how could you be more different? But then I thought, well, maybe you're both sort of gearheads, essentially.
Yeah, that's a great question. So my panelists here tonight, they're going to talk about some really, really, like we just heard about this awesome exotic, place with brown bears that might eat you in Russia. But, I get to go to great exotic places too, like redneck tracks up in the Midwest where you don't have brown bears that are necessarily going to eat you, but you're going to have drunk fans drinking Busch Light that are Ford fans, and you show up with a Chevy. Right?
The local fauna, yeah.
And not only that, but you have a button-up shirt and you're a scientist at the computer, and they're like, what the hell's that? And you laugh, but it's true. As a matter of fact, if you put up slide number 39, this is... That's my colleague Danny Bocci, and what you see is the race car and the race team we've been working on. That's a 2010 Camaro the 2010 Camaro Project Green car we've worked with, which this is up in Wisconsin. And the typical racer today, still in racing, they use carburetors, which is basically kind of like a controlled commode bulb on an engine. I mean, that's like 1920s technology. And here we have an all-aluminum construction, fuel-injected, E85 powered with catalytic converter optimized race car. And then Danny up there, my colleague, is working on the program to optimize the engine for that race. And we had people stopping by and saying, what the hell's that? And so that was kind of interesting. And the other thing before we go on, if you'll notice to the right of him in the windshield is a little bobblehead doll. This is Evil. I got to talk about this. This is Evil. It's the same Evil in that windshield. So I'm a little superstitious. And before I came to work at Argonne, I worked at General Motors developing advanced engines. And before that, I was at Wisconsin doing engine design research. And I've had him since Wisconsin, so we've been together about 14 years. He's my good luck bobblehead doll. And so whenever I had an engine or a new program, I'd always tape him to the engine, and the engine would be running and testing, his head would be bobbing. And I've never lost an engine, never. So this is the first race we took out with this car to up at Oktoberfest in Wisconsin to race. And so I brought him for good luck, and we taped him to the dash. And so in one of the qualifying races, Dalton's here, the driver's driving around this half-mile track, 115 miles an hour, just blazing. And he goes right in front of us along the straight, and we're in the pits waiting for him to come pit, and all of a sudden we see this white thing bouncing down the track, and we're like, and so one of the crew mechanics says, I think that's evil. And sure as hell, evil flew out of the car around the turn and probably flipped about 175 feet down the track, end over end, and stopped right in front of us on the track. If you get a chance later, you can come take a look at his battle scars, but we did pretty well that night. His luck still held out, and yeah, so. He's still alive, he's still with me.
So there's some common ground there culturally, maybe.
It's fascinating being a science guy in that type of community.
So, yeah. Out of curiosity, at a pit stop, do you bring out an Ethernet cable?
Actually, we did to download data because we were very precisely measuring. In this particular car, we had our own data acquisition system, and we had to very precisely measure the fuel rate because we were taking a look at well-to-wheel greenhouse gas contributions. We had to do some very accurate calculations. And so the answer is yes. And every time we did that, they'd be like, what the hell's that?
You got to go wireless.
Instead of, I need the number 78 jet for the Holly, they're like, what are you doing? This is
And did you win?
we didn't win. We didn't win that night. There was out of 63 or 4 cars, we got 15th. But it was a huge, actually we think it was a huge win because the technology that we showed here, our car demonstrated that night a well-to-wheel greenhouse gas impact similar to a 4-cylinder Toyota Camry running around town on regular unleaded fuel. In addition, we displaced 83%, about 83% of our petroleum use using renewable fuel, cellulosic ethanol. And we saved the racer $30,000 by the particular engine and fuel we used. So it was huge, a huge win.
So
we're going back, by the way, to the track. We're racing it this October, and we have 150 more horsepower this time.
Ah, okay. So ask that question again next time. Yeah. And have you ever gotten behind the wheel of one of these things?
I haven't. When we were doing some testing, Dalton Zier, the team is Zier Racing out of Port Orange, Florida, they'll let me drive the car, and I kind of grew up as a motorhead kid, and so I'm looking forward to it. But if you go to slide number 34, this is Dalton and I before in the races. I look taller, but he's got about 40 pounds on me, and if I get in that suit, I'm swimming it. His suit was too big for me to actually drive. One funny story that night, though, that we raced, we had 3 different legs and a couple qualifyings. Since this team volunteers their time, it's a really cost-effective program. They believe in the message and they volunteer their team in the car. We don't have to buy it. We just show up with our technology and work with them, which is a pretty amazing story. We volunteered to be pit crew that night, Danny and I, and they had one other guy. And so we're racing, and the way that we had this, the engine and the way we set it up in the car came together. If you go to slide number 33, this is actually this is in their shop down in Florida, prepping the car to ship up for our first round of testing down in Florida, which wasn't racing, it was just proving the technology. Then if you go to slide number 40, this was actually at Argonne National Laboratory just a few days before the race where we were putting our data acquisition system in it. You see one of our chassis dynamometers in the background. So we go up there to pit for the car, and Danny and I are engineers, and I'm kind of a wrench head and he's a wrench head, but this isn't our professional job. We get up there, and the way engines work, they're air pumps, and the cooler the air you get into it, the more power you're going to make. Except the way the engine was set up, we didn't have time to get a cool air induction to the intake of the engine. So the engine was basically sucking hot air out of the engine compartment to run, which was costing us power. So we weren't quite going as fast as we wanted to, and Dalton came in and he said, hey, why don't we just route the cooling ducts to the brakes up to the intake of the manifold? And I thought about it and kind of did some rough calculations. I said, we might pick up a couple percent maybe. Yeah, we should do that. He's like, yeah, just do it. So we did it. This is one of the night things. We could see him going around with his brakes were cherry red. And we're like, he finally pulls in. He's like, damn it, I've got no more brakes. And so Danny and I are trying to take off this system and rewire. And the stuff was so hot, it burned through the glove. I mean, I still have scars on my hands from trying to get these red, because we're in the middle of a leg and we have to get this thing up. So, here's a couple of computer guys and scientists just wrenching on this car, burning our hands. It was ridiculous, but it was a lot of fun.
That's great. Thank you. Well, we'll move on now to Gina RAMEIKA, who is on her home turf here. Maybe you could talk a little bit about your work here at FERMILAB.
I will. I have a few slides to help guide it. If you could, slide 46. So there's our companions here at FERMILAB. And I just want to start by saying I've been working at FERMILAB for 30 years now. And so I've done a lot of experiments, and I've been really lucky to be able to do a lot of experiments here. I've watched the lab evolve, through different machines and different programs. And what I'm going to talk to you about tonight is probably the most exciting one that I've worked on. And I'm not currently working on it anymore because I've moved on to new programs that we hope to lead us in the future. But this one is by far the one with the most outreach and interest to touch the community. So if you go to slide 48. So one of the projects we started working on here back in the mid-90s was to study what's called neutrino oscillations, because it was discovered that neutrinos change their flavor. You can create them in one state and they change to another. And one way to really observe and understand that is to study it with a neutrino beam that you can create at an accelerator laboratory like FERMILAB. And this effect is manifested if you go over a long distance, if you send the neutrinos through the Earth over a long distance. And so we decided that we had a long distance opportunity. In the early 1980s, there was an experiment done in northern Minnesota in an iron mine. You saw a little bit of that from Lauren's clip at the beginning. There was an iron mine up there which provided a lot of economy, and then it closed down and it became a national park. And about that time, some physicists from the University of Minnesota decided that they wanted to search for proton decay, and so they needed to go deep underground. And so they established a small laboratory there. So when this idea of neutrino oscillations came around in the mid-90s, about 10 years later, it was a natural thought to say, what if we sent the beam from FERMILAB to that mine in northern Minnesota? There was even a detector there that we thought we could use, but as the calculations went on, we decided we actually needed a new detector, something that would have higher performance. And so we started what we call the NUMI project. It was neutrinos from the main injector, which was a new accelerator being built here, and we had to shoot neutrinos from the main injector up to northern Minnesota. So one of the fun things was trying to tell people that we're not building a tunnel from here to Minnesota. We're going to build a tunnel to get the neutrinos started. Once we create them, they're going to go through the Earth without being stopped. And enough of them are going to get up there to this mine that we're going to be able to detect them. So if you go to slide number 50, the place we were sending them to is this town called Tower Sudan, Minnesota. It's got a few hundred people population, and so it's remote, but it's not that remote, okay? It's about 20 miles away from Ely, Minnesota, which a lot of people might recognize as, the launching place for the Boundary Waters and canoeing and things like that. So you have a 20-mile drive into a place where there's some real activity. And so we decided we were going to do this experiment. It was kind of unique, and we're going to have to explain it to the people up there. What are we going to do? They kind of got word right away from the university people in Minnesota that this was going to bring some jobs, it was going to bring some life to their town, and so they were quite excited about it, but they didn't really understand it. So even before we took one shovel of rock out of the mine for the experiment, we started going up there as a group every summer. We used to have a collaboration meeting up there that we called Week in the Woods. So it would get us away from FERMILAB or our universities and all sit in a hotel or a lodge or the community college and go, a real collaboration meeting. But the highlights of the meeting every time was really what we did after the workday, which was head into Ely or into town and go to the bars and the restaurants. And you can imagine these small towns with 150 people, 150 physicists coming in, and they ask you what you're doing, and you start to explain it. But it was amazing. I mean, they were just so excited and enthused that they kept inviting us back. They put us on the local radio. They hosted an event at the community college. And so, the people up in Tower, Minnesota probably know more about neutrinos than, the general public. So it was really fun. And if you go to slide number 54. So you saw this a little bit at in Lauren's piece. This is the head frame of the mine shaft that we're going to use to get down into this underground space. This is about a 6-meter by 6-meter elevator that takes you over about a 3-minute period down a half a mile underground. So when you think about working underground, everything that you do there has to go up and down through this small mine shaft. And so we had to use that to do the first big part of this job, was slide 55, was we had to excavate a huge hole in the ground. And so we had to drill and blast and dynamite the rock out, take it out through the shaft. I shouldn't say we. This is where we hired a lot of people. There were, round-the-clock crews of people, mining company excavating this. So we were pretty popular. We had this good job going. We finally got this big hole in the ground excavated, and then go to 53. And then we had to bring every piece of our detector that we want to build down through that shaft, piece by piece. So literally, this was an example of building a ship in a bottle. And so when we were done, we had a 5,000-ton detector of iron, made of iron. It's kind of funny, people laughed. They took iron out of the mine in order for us to bring iron back in order to detect these neutrinos. But again, it was such a popular activity that a local artist came in and drew a mural on the wall to describe the history of neutrinos. There's some intricate things in there. And so it was a really beautiful environment. And so we built this detector. It took about 2 years to build it, piece by piece. And then when it was all done, if you go to slide 52, we have this huge completed detector and lots of space underground. And it actually amazingly looks like any laboratory we have here at Fermilab sitting up in one of our beam lines. So we've really outfitted this into be just a key place. And then, so in fact, the next slide is 51. So, and in fact, what we do now, and this is the important part, in addition to the science that we get to do at this place, we get to do a lot of outreach. And this mine, which was always of interest to the locals as a historic park and so on, has become a science lab where 20,000 school kids a year come in, visit our lab, hear about neutrinos. And we have displays and outreach and all that. So it's really amazing to be able to take this message and connect what we do here at a huge national lab to a small town in northern Minnesota. And finally, someone mentioned earlier about being in remote places and it's not too comfortable and you're living in the wilderness. Well, I have to just point out the exact opposite on my last slide, which is 49, which is in our lunchroom. You'd never know you were half a mile underground. It's quite comfortable, and meeting rooms, conference rooms, internet connections. So it's quite a place to do science. I'm very lucky to have done it.
So Gina, just briefly, what goes through your head as you're going down that elevator shaft?
That's an easy question. You want to keep the bats off of me. Okay? That's the one thing is before we built this, we actually had to go through some environmental issues, including bat mitigation, to understand what the impact of this was going to be on this local collection of bats. And the fact is we don't disturb them. And they are in the shaft while you're going down, and they are flying around your head. So that's what you think about.
You're mostly thinking about bats.
And then another point, you go down and you have a hard hat on, but it's very, very dark. And I asked when I first went down there, why is it so dark? Can't we put lights in this place? And they go, oh, the miners would never like that. That's not macho. So it's dark because they don't want to put the lights in.
It's dark because it's macho. Does it, do you feel the earth above you when you're down there? Or do you get so used to it that it's like working anywhere?
No, it's really like working anywhere. In your mind, at first you feel perhaps a bit claustrophobic when you first go down. But as I said, when you get down there, you get off of the shaft, and it does look like a mine. You saw a few pictures in there, I think, of the tunnel, and it looks kind of grungy. And then you open these big double doors into this laboratory, and you're like, OK, this is fine.
It looks like you're just in a big basement.
You don't even feel it. You just feel like you're in an experimental hall.
Yeah.
So you get used to it.
Well, one thing that I imagine must be different is that if you forget something,
absolutely,
you're in trouble, right?
That's correct. You have to plan carefully. And the point is that the way it works, the state park owns this facility. And in fact, every trip up and down, we pay for. I don't remember the cost, but it's $130 a trip. So you think twice before saying, I forgot the screwdriver. And
That's great. Well,
I'm just kind of curious, how much dispersion is there? How good does your aim have to be if you want to hit something 2 states away with a neutrino?
So I can explain a bit about that. This neutrino beam has a lot of dispersion, and that's a really important factor. This little detector is very small with respect to the beam by the time it gets there. The beam is actually many, many kilometers wide. And so it's all over the place. You explain that to people, that they're sitting in a beam of neutrinos. And in fact, I'll remind people, you know, if we had more time to talk, I would point out to them the next experiment we're doing using this facility goes 100 kilometers north. This is called the NOVA project, and we're building a detector there to see the same neutrinos that we're sending to here. So they're just all over. And so,
but there's enough of them, obviously, that you're going to hit.
So one thing to note, people will ask this, that's 5,000 tons of iron down there. We send the beam from FERMILAB, and we record about 5 neutrino events per day. So
and that's a good day.
And that's a good day, yeah.
I wonder what advanced civilizations, like 10,000 years, when this is forgotten, like, you know, we see caveman drawings on the wall, and we're like, whoa, look at that. Like 10,000 years are going to go down, and we're like, whoa.
What is this?
What are they going to make of that?
You know,
they learned to process the iron in the mine.
Yes. Wow, that's amazing. Well, thanks, Gina. So, Doug Sisterson, maybe you could talk a little bit about your work.
Well, mine's a little bit different than my colleagues up here. That the climate research facility that I'm associated with is a national user facility, and it's like a beamline, except that it doesn't fit inside the gate of a laboratory. We have to bring the observations to the world, and so our laboratory is the world. It's sort of a lab without walls. So we have clusters of instrumentation that we like to fancy too, the remote sensing devices, but really we measure just everyday weather, and we do it 24/7, and we're able to get the data back to the scientists in near real time. What's interesting is that we need to be in the places where scientists want us to be, and we have permanent sites that are in Barrow, Alaska. It took us 5 years before we could get our first instrument into Barrow, so being a good neighbor takes a long time to establish. We also have sites, permanent sites in what we call the tropical Western Pacific region of the world, where we talk about El Nino, La Nina. So we have sites at Manus Island in Papua New Guinea. We have sites in the world's smallest republic, the Republic of Nauru, and in Darwin, Australia. And we have another one of our largest flagship sites. We have a broader collection of instruments that is in rural Oklahoma. And I will tell you, I have been spending many years down in rural Oklahoma, that you feel like you've left the planet when you're in the middle of rural Oklahoma. But the other part about the facility that we have is that we learned over time that the real challenge, the scientific challenge, is to look at where the observations and the climate forecasts don't agree. We're not about global warming or so forth. We're trying to understand the physics that go into understanding how Mother Nature works, and then be able to put that to equations that we can put in models and use that to test our knowledge. So not only do we have to go forward and predict what's going to happen in millions of years, we have to go backwards and be consistent with observations that we saw millions of years ago. And so we learned to take this group of instrumentation, core group. It fits in about 7 semi-tractor trailer trucks that fits conveniently in a 747 chartered jet. And you can fly it around the world to places where observations of the data and the models don't agree. And that tends to be, by Murphy's Law, places that are not like Honolulu or and so forth. So we have some really interesting stories to tell about not so much the extreme science that we're doing, but where we have to go to just put our instruments out for a year, meet the good neighbors, and be able to establish the good relationships with the locals in order to set our instruments up to provide, you know, the climate data for about 5,000 scientists around the world.
Yeah. So you work in so many diverse kinds of places. I mean, are the concerns that you have to sort of bring with you the same or completely different in a place like the Arctic versus some equatorial island somewhere?
That's a really good question. You know, we can build an instrument, we can harden it for one environment, but something that works in the tropics doesn't work really well in Barrow, Alaska. And so that is quite an effort. It's a really good question to take traditional instruments, some that aren't traditional, and get them to work unattended for years at a time is extremely difficult. We have computers that tell us whether the instruments are working, and we can, over the internet, kind of wake them up or reboot them or whatever, but we still have people on site that computer says it's time for us to go out and do something with that instrument that we can't do remotely. And it's interesting. We bring some big technology, and we always like to cite it with local technology. So I brought a couple of slides that might show that. I have to get my neighbor's slide in here. So slide 14, my first trip abroad to a remote region was to Niamey in Niger, Africa. And we conveniently parked our big part of our facilities. The only safe place and secure place we could do was by the airport, but it didn't really get us into the environment where we really wanted to make the measurements. So we were able to take a collection of duplicate instruments and locate them a couple of 100 kilometers away that were close to the Sahara Desert, which is why we were there. And the first thing that you realize is that there's it's a gravel road for about 6 hours one way to get to our site in Banizambu. And it's a warm period of the year, so there's a balance, sort of hydrological in nature, between hydration and deposition, if you will. And the first thing that you figured out after about 5 hours that politely you could hold it, but when you got there, there really wasn't anything there either. And so this was our first experience at a roadside rest stop on the road to Banizambu. In the next slide, we were able to successfully get to where we wanted to co-locate our instruments. We knew that there was a meteorological site in Banizambu, and we were pretty amazed. We're bringing our $10 million worth of remote sensing instrumentation, and this is what we were co-locating with, which, by the way, is a pretty high-tech site in Banizambu, Niger. And so we immediately knew that we had a little bit of problem because some of our fancy electronics have to be out of the elements in the environment. So we said, well, guys, we need a shelter, we need a building. And of course, the locals said, no problem. And in the next slide, in about 5 days, they built us a pretty snappy little research building, which actually was pretty good. And we were very excited at the ingenuity and the excitement of villagers that were willing to help with us. And we were never at a loss of finding helpers. In the next slide, helpers were extremely eager to come and be with us. And I think that everywhere we went, that really the first thing that people would say, what can you tell and teach my children? It was really interesting, whether you were talking to kings or parents. It was like, what can you do in your setting and tell me what it means here? So it was very exciting. We could talk about scientific knowledge, but also traditional knowledge. And just to let you know, in the next slide, there were also curious neighbors. that was really odd when you look at animals for the first time and you realize that they're not in a cage at Brookfield Zoo. And so it makes it pretty exciting. And in Barrow, Alaska, I didn't bring a picture of that, but it's pretty interesting. And a flight attendant on a humorous day will tell you you've left the lower 48 where you've gone from the top of the food chain to somewhere in the middle. So we have some pretty interesting stories about polar bears and so forth. The extreme part of the research is trying to negotiate and find partners where you can bring your equipment and do this in countries that sometimes are not as friendly as you'd like them to be, and in strange places so the science can be done. For example, in the next slide, we were in a place called Zhanyi, China, sort of north-central China. We were getting near the foot of the Gobi Desert. And this was, sort of 1,000 miles from anywhere. And there was this really neat sort of pagoda structure, and our lab was in the background there. And there was, we asked, well, we need some electricity and, internet connections. And the next slide shows sort of what we had available. So sometimes you have to be a little bit creative about the environment that you're in and make do with the equipment that you have. And also, when we talk about the vastness and the remoteness, the next slide was looking in the other direction. And this was our research area. This is the measurements we were trying to make over the influence over the desert over weather. So it's a great fetch, but as we've all said, you know, if you forgot some duct tape, it's a long way to a Radio Shack. So you have to be really well prepared when you go there. And by the way, Eric Isaacs is not here tonight. I just want to say that we have a safety plan for every one of these environments. We have proper training.
What's the safety plan for elephants that want to eat your equipment?
Keep your distance. Lots of peanuts in your pocket. So that gives a little bit of background of I mean, we all talk about the high-tech things that we find in the journals, but this is a wonderful opportunity to sort of bring to life the challenges that we have to bring the science to the world that isn't really science-friendly.
Yeah. Thank you. So it feels like we're just beginning, but we're actually kind of running low on time. So I would like to open it up for all of us, all of you, for about 10 minutes or so, and then we're going to open it up to audience questions maybe for another 10 minutes or so, and then we're going to have to wrap it up. But to start with, so it's not obvious that the skill set required to do the basic science that you're all after and to do it in these crazy places are the same, right? Because you have to be, first and foremost, top-notch scientists, researchers, technicians. But you also have to be athletes, you've got to be diplomats, you've got to be teachers, you probably have to learn first aid. I mean, all this stuff. So is there a disconnect, or do you find that there's something that lets you kind of, is there anything that doesn't come easily to you? How do you kind of maneuver in all those very, very different kinds of skill sets? And I'll open it up to anybody who feels like answering.
I will tell you that I think probably all of us would share that passion is probably the trump card that you have to want to do this.
And is it that passion will get you, will keep you safe from the bears? And is it the same passion that will make you persevere on your graduate thesis? I mean, is it really just the science is what animates you?
I would agree. I would definitely agree with Doug. And if you're passionate about something, it's contagious. And it could be anything. It could be playing a violin or racing a car or running from bears. I mean, you know.
We run at them. You run away. Yeah. Your chances might be 50-50 to run at them.
There's a peanuts or blueberries. Take one of them.
Well, but we're also smart. We've learned, like in Barrow, we would have a polar bear shotgun person, and so is our job.
They didn't trust us with guns.
Well, we are actually able to take shotgun training, but not me. And so the issue was that we would hire a shotgun person, and the idea was that the polar bears would sort of sneak up on you. Most people don't know that they can outrun you, and they can swim up to 80 miles. And so, you know, that's...
Carrying a person.
Carrying a person.
And I think they do climb trees, by the way, Albert.
They do.
But you have to find just the right size, you see.
Yeah. But the interesting story is
the
that
mental
shotgun,
things we do, too.
Yeah, our manager would tell us that in the training that, you know, that the idea is that if we were under attack by a bear, that because they're a protected species, they have a shotgun. Well, that's not going to bring down a polar bear, but you shoot it in the leg, and therefore it would slow it down, giving us all time to get away. But then the shotgun guy, if he had a really good sense of humor, would tell you, no, that's not the way it works here. And that's why we always bring a team of people.
Who gets shot?
And so you be nice to the guy because he says, no, we shoot the guy we don't like. I don't like in the knee. And we all just walk out of there. So you may have passion, but it's wise to work in teams with different personalities and attributes that at least there's one survivor left.
And do you, I wonder, I mean, so in each case, there is some, I guess you'd say, risk involved. I mean, Forrest, when you get behind the wheel, there will be risk. And I wonder, in what ways do you, how does that play on your day-to-day? Are you thinking about that stuff? Do you have ways to cope with it that you develop? Or do you just sort of try and focus on your work and put that out of your mind? I mean, how do you kind of wrestle with that?
You know, for me personally, I've got to say, and it's like I wasn't running for bears or anything that crazy. And my exotic places were small racetracks in Middle America with people that weren't necessarily, you know, greenhouse gas, renewable fuel. What the hell is wrong with you? I mean, really. And so you're that one. All the salmon are going upstream, and you're like, no, it's easier to go down. I'm going the other way. And it's a different mindset to have. But I mean, for me personally, it sounds kind of strange. Honestly, I grew up that punk rock kid that, like, okay, I'm going to look at what I think is right, and I'm going to stand by it. And I'm pretty passionate about the idea of coming up with domestically generated sustainable energy solutions that My twin brother's daughter can race cars 20 years from now and not worry about it if she's so, and she does. She loves that movie Cars. You ever see Cars? She's all about it. She loves it, and I want her to have that opportunity if she wants to, without, you know, us using that resource. And so for me, it's easy. I just believe in it. Whether somebody does or not, that's okay. I'm going to keep swimming in that direction. And I tell you, we did come across a lot of resistance, but it's really from the stuff we've published and talked about, it's really catching on, and I hope it does become kind of this grassroots change that suddenly, believe it or not, environmentalists can be these race car drivers. Believe it or not, it sounds crazy, but even in the American Le Mans series we worked with for 2 years, we've displaced 45% of our petroleum use, and the greenhouse gas reductions almost, well-to-wheel basis, 40%, and that happened in 2 years of working with that organization. That's pretty impressive. I mean, that beats the government's goal by 2020 for domestic transportation. So these solutions exist. You believe in it, and you just go, and if you get beat up, well, you did the right thing.
Well, I have to say, it weighs on me.
Yeah.
I mean, I think about it before I go into the field. This is being videotaped, so. But no, it definitely weighs on me. I mean, the helicopters we fly in are sort of Afghan war vintage. That's the first Afghan war. And the things we transport, you know, we've got a 55-gallon drum of fuel with us, kind of loose in the back. The things I don't particularly like. The bears, they're beautiful, majestic, but they're just not shy enough for my taste. There are a lot of things that I worry about ahead of time, try to do the best I can to take all appropriate precautions, and then when I'm there, I'm in the moment and driven by the science and driven by the fact that for whatever reasons our planned 2-week field season has been cut down to 7 days and we've got still the same amount of stuff to do, so we're working around the clock. And I mean, there are a lot of things that take over when you're in the field, so that you don't worry about it so much then. Occasionally you get the real world intruding, like back in 2005 when we were there. It's a fairly remote environment. We have a couple hours of generator usage a day, which makes it tough to do things like DNA extractions, where we take it's called a bead beater there. You want to rupture cells, extract the DNA from them. You've got to smash them around with little glass beads and use a lot of different kits for extracting the DNA, preserving it the best we can when we don't have refrigeration. We're out of touch with the outside world, except we do take a satellite phone, and just as a safety measure, we check for text messages daily. And so back in 2005, at one point we got this message, hurricane hits New Orleans, levees break, 1,000 people dead. And we're in the middle of nowhere. We don't know anything except those bare-bone facts. We worry a lot about family on the outside, and we worry about ourselves on the inside. But it is a different way of doing science than being back in the lab here.
And how much of the pleasure or the gratification that you get comes from getting a good result, getting a good measurement, getting whatever, and how much of it comes from working in this very unorthodox place? What do you think? Gina, I mean, would you do neutrino research on the surface if you had the choice?
Like I said, to me, the interesting thing about the remoteness is literally the distance, you know, where it is in northern Minnesota and the people there and connecting there. The underground is not that important. I mean, we went there because there was a whole, you know, there was a place to go. But when you ask about, you know, what's most important, I think the outreach that we can do in these places is equally as important as the results that we get. And so to me, it's a wash. I mean, I do both, and I wouldn't rank one higher than the other. We have to do both. We have to do science, but if we do it, we have to connect with the people out there and let them know why we're doing it and help educate them. I mean, you know, again, we bring thousands of kids up there each year, and we want to show them what the science is like, and they think it's pretty cool to go underground and wear a hat and then see a big detector. Yeah. So.
And Doug, you're nodding your head. Clearly, the human interactions are a big part of what you get out of this work as well.
Yeah, I was thinking that. As a matter of fact, I think the best story I can tell in that regard, although there's probably some village in Ben or Zambu that just learned about Costco trail mix. They love it, so did I. But I left all my packages there. It was actually in Barrow, Alaska. It's interesting that with the Inupiats, and there's a strong desire to protect their culture in that part of the world. And it's a really harsh environment. You think, God, who would want to live here? But they do, and there's fierce pride in that. And when we come in with computers where technology is a threat to their culture. And so the first thing we had to do is figure out how can we bring all this equipment and technology up here and not make it a threat. We were going to donate computers to the school. Oh, wait a minute, it's got the internet. They're going to, no, this is evil, you know. And so we sat down and we talked to the elders. And there's a certain protocol, and as we learned about their storytelling about, the winter that never came. And so we started thinking about that with the scientists we had with us, and we looked back to some of their storytelling and what we would call traditional knowledge. And we learned that the traditional Gesundheit knowledge would stack up really well with the eruption of Mount Krakatoa and the scientific knowledge. And suddenly, for the first time, we started this dialogue. So we actually have in our educational web pages talking to fishermen about what is the climate like where you are. Tell us about your fishing experiences. And they were almost as good as our scientific data. It's amazing. We don't go out earlier. The sea ice is not forming as quickly, and we have to go out further. And so suddenly, there's just a whole area of science to go out and reap the benefits from in traditional knowledge. And I think it's taught me that talking with these people, that you learn that, yeah, okay, just because it doesn't go through the peer-reviewed scientific process, does it make it wrong? And we can find ways to integrate that and actually be quite, it's a personal revelation. So we can make peace. We actually gave them the computers because we found out that the Inupiats pass on their language, which is symbols drawn with sticks by the elders in the permafrost, and we allowed them, we showed them how they could make calendars using these letters that their parents and grandparents had showed them, and that technology could be used to help preserve their traditional knowledge. And so I think for me, doing the science, it's great to see all these scientists do their thing, it's great, but for that aha moment of being in some place you could never imagine yourself being, working with people, they're the same everywhere, it was really cool.
Well, that's a beautiful place to make a pivot, I guess. Thank you guys all for those reflections. We want to take just a few minutes to open it up for questions. If people have questions, and if you don't mind, if you'll indulge me, because we're recording, I'll repeat the questions so we'll have it on microphone. But if anybody has a question, I guess just raise your hand and I will point.
Don't be shy.
Somebody has to break the ice. Yes.
Why Russia?
Why Russia was the question for Albert.
Because we enjoy going through customs in Moscow.
You should have said bug
Well, so we are interested in studying a particular kind of microbial metabolism that's called anaerobic carbon monoxide oxidation, or anaerobic carboxytrophy. And this was first discovered in the Kuril Islands. It had since been documented as existing in some hot springs in Uzon caldera on the Kamchatka Peninsula. So we went there because we knew we could find organisms that made a living off of this metabolism that we were interested in. It's not that one couldn't find it elsewhere, but it was in large part because it had been discovered there. There was this feeling amongst the microbiologists I was joining that if you want to find organisms that essentially eat carbon monoxide, they use it as a carbon source for making up biomass. They use it as an energy source to drive the processes that lead to building new cells. So they turn, the reaction is CO plus water. They're using water to oxidize the CO. And they make CO2 and hydrogen gas. So there's a little bit of DOE biohydrogen. DOE, you should be interested in the biohydrogen aspects. I'll plug, maybe. But most of our work thus far has been funded by NSF. Do you really want to let them get ahead on that? And thank you to NSF if you're watching.
Send me an email after this.
So their feeling was, where do you find reduced gases like carbon monoxide? Well, you go to volcanoes and hot springs. So it seemed like a logical place. And then some of our geochemical measurements, which is what really makes me so enthusiastic about this, is the discoveries we make. I feel like if I'm sitting in a lab trying to model something on a computer or set up a pure culture or a mesocosm experiment in the lab, I'm missing a lot. There's so much that you fail to capture in terms of getting the processes right that you need to be studying if you don't actually go to the place where things are happening. So we go there, and what we've discovered is that there's a lot more carbon monoxide being consumed by these microbial communities than is coming up in the hot springs. And it suggests that there needs to be some kind of organism or a group of organisms that are producing CO there. So we've discovered through literature searches that there are particular sulfate reducers and methanogens that can make CO. It seems that there's a really vigorous carbon monoxide cycle in the microbial world that hasn't yet been appreciated in the way that I think we're appreciating it and soon will be broadcasting. So why Russia? Well, we knew we could find some interesting results there. It was a great experience collaborating with our Russian colleagues. I would gladly do it again, but boy, the logistics really just throw you for a loop sometimes, and that's the one big downside of this.
It's easier than Mars.
The biggest downside. Yes, yeah, sure. Well,
so there's that. Yes.
I keep thinking of a radio ad that was running a lot last spring, questioning the value of spending public money on what you might call extreme research. I think the examples they were using were something like fossils in China and turtles in Florida. I can't, maybe somebody else remembers the exact examples. But how do you justify to the part of the public which doesn't accept the results of knowledge, just pure knowledge, as being valuable, what you're doing?
So the question is, how do you justify the expense of your work in general, but especially the projects that you guys are working on are very expensive, to a public that might be skeptical of the value of science? Yeah,
boy, could I take a stat? Sorry, but I just want to jump all over that. Because I think it's just so unpredictable what's going to be discovered. You set bright people up who like to tinker, who like to be creative, who go and observe a new environment, and if they find compelling scientific reasons that aren't particularly applied, the applications will come. And I think with, for example, extremophile research, that's been proven many times over by the discovery of Taq polymerase. So if you look at how DNA is replicated in organisms that live in hot springs, it happens fast and it happens at a high temperature and it requires thermostable enzymes that the elucidation of these pathways then led to biotechnological revolutions with regard to amplification of DNA, sequencing, all sorts of things that, we would not have the human genome sequenced at this point if it hadn't been for people studying extremophiles, not because they wanted to sequence the human genome, but because they were curious. And there are people who are now looking at energy issues from the standpoint of understanding, again, thermostable enzymes. How do you take biomass that you can grow readily and convert it into a biofuel? There's been talk of bioethanol, but also there are other fuels that can be made. Butanol is a good one, high energy. Yeah, so you can store a lot of energy in butanol. It's not particularly corrosive. And so there are questions about how you can take more complicated macromolecules and break them down into fuels. Well, one easy way to study this is to go, again, to hot springs, give the potential fuel to the hot spring, and study who colonizes it and what they make out of it. And again, we wouldn't be in a good position to do that if it weren't for the more generalized research on these springs, understanding the particular microbes and their strategies for living in the ecology of these places. So. And I know that you guys have equally good answers, so I'm going to step back. But
I have a little bit different take on it from my side, and that's an excellent question because, and I'm personally, I'm a real free market guy, and I like that, and I think that's the power of America, me personally, and I've taken that as a challenge in my work, and so like I made the blurb earlier. This team, we found them, and they donated their time. Our engine was donated from General Motors. Circle Track magazine got us all the other parts that we need. And they did it because they were passionate like I was. They just happened to see the value of, wait, we could make a change. And we're going to donate our time, our car, our driver, and all this stuff. And I had to show up with the science. And that's what we did. And this was, I think, in this particular case, it was an instance where we were able to leverage very cost effectively people that just felt right about it and get the word out and ultimately we just came back we took this car to Las Vegas, a show called SEMA show, the Specialty Equipment Manufacturers Association. It's huge. It's at Las Vegas Convention Center. It's a huge aftermarket. The automotive aftermarket industry is billions and billions of dollars. It's huge. And we presented this in the car there, and this could become an industry unto itself that would actually create jobs and business and opportunities, renewable fuel, advanced technologies in both race cars, hot rods, and everything, and could be leveraged in the OEMs ultimately. So for me, it was looking at the end game of what could be and to build business and opportunities.
So I can comment also on your question. I mean, I have heard, you hear that criticism, that there is this criticism out there, but as I said, I've been in this business for 30 years, and it's really hard for me to recall a time when I had to confront that with anybody. My dealings with the public have almost always been positive. I sit on a lot of airplanes, I've been to this, you know, these small towns, we've been to conferences, and you end up talking to people in the towns where the conference is. And by far, it's really, really positive. People are very interested in the science that we do. And so I think there is a minority of people who think, oh, it's not worth the taxpayers' money. But I think they have an agenda. And when I do run into that person, I'm going to give them a hard time. Because I think in general, people do value the science that we do. And they also understand things that we talk about, that it's a cyclical thing. It's not like we're asking the government to give us $1 billion to sit here at FERMILAB to, you know, make fancy buildings and, you know, pay high salaries. We take the money and we cycle it back into the economy. Like I said, we build holes in the ground and we buy things from industry. We advance technology. All of this is, you know, it's outreach of the research. So when someone says it doesn't seem worth it, I would go through the numbers with them and explain to them how we're using their dollars to get back to them as well in many, many ways, including education.
I have an interesting approach to that one too. I remember once we had to have one of our Office of Science reviews by the BRAC, and that was the agenda. How can we demonstrate that our climate research facility is being cost-effective and efficient? And so I thought about this. You know, these arguments are nice, but I'm now in front of people that want to know how their $46 million is being spent. So I thought about this, and I decided, you know, we're a user facility, we're a business, so we're about collecting data. And so I could figure out that in one 24-hour period, we were getting highly processed, quality-assured data file. So one data file for each wind speed, wind direction, cloud cover, whatever it was. And I could say that in, you know, the first year of the program, we were out in the field and we were collecting this data. In 1995, it was $4,500 per unit, per highly processed data file. And by 2009, it was a little less than 45 bucks. And so you could see this. Now, I mean, but it was kind of it's a challenge to us to how to convey what we do in sort of a layman's point of view to understand where all those beams are going. So it was just a more practical way, but we found a great deal of success in showing that the product, as we got more volume of data and usable data, the cost was substantially cheaper.
But it's a great question, because I think as a whole we do a lousy job of communicating the value of science to people who don't encounter it on a daily basis. And so I think that's probably why we also, all of us, get involved in outreach activities, because of the need to let people know how exciting this is and how it, you know, in very real ways, it feeds back on reasonably short timescales to advancing the economy here for everyone. But it's a good question.
Thanks. Right here?
Yeah. As I understand the nature of your work, it seems to me that Albert and Doug are both looking at studying constant processes, whereas Regina and Forrest are much closer to the experimental model in terms of you do something, you see how that works, you adjust it and try it again. And I'm wondering how these two different work environments affect the nature of the work process, and whether there are interesting overlaps either within the two categories or between the two categories in terms of how the work process affects the paradigms you're using or the end results.
So if I could, the question has to do with the difference between studying, basically observing natural processes and studying those versus setting experiments into motion, how that changes the way you approach things in the various spheres that you work, and whether there's overlap.
Well, in any situation like this, it's almost the difference between basic research and applied research. So the first thing is to try to go out there and understand what are the processes that drive things, and then as we become familiar with those processes, how can that be used to solve a real-life problem? So.
Yeah, and obviously I'm more of an application trying to use these different, because if you were to take a look at my specific project, we've integrated a lot of different things to make that happen. And I always say, you know, in God we trust, everyone else brings data. I love that because when my data tells me it doesn't work, next.
Yeah.
Next? What are we doing next? What's my next step? And I love that because it's like, or then when occasionally you get that carrot and it works, you're like, oh, hot damn, you know, this is great. And then you struck gold, and hopefully you can make something good happen. Because ultimately, I do want to make change. I don't want to just see it get shelved. I'm getting to speak to you and show you some of the results we get, and hopefully, you never know when that one person will make the difference in the world. You never know. And history's full of wonderful people that did in a positive way, and so maybe this is a chance. You never know.
It's an interesting dichotomy that you pose. I've never even thought about it that way for my own work. Here we're presenting kind of glimpses of some of what we do, but certainly with my field studies, that's just one aspect of kind of a cycle of go make some observations, collect some samples to then work with in the lab, do some experiments in the lab with these samples, develop some couple reaction transport models to describe what's going on, model the thermodynamics of both the geothermal system and the microbial, the linked microbial metabolisms here, and then go back and see if what we think was going on is actually happening. And so there's an awful lot of, and there's also a lot of sensor development and tinkering with things, saying, okay, do I even believe the data? And how can I be confident that I believe the data, and what do I have to do better to have a working instrument? And the same is true with the microbiology in the lab. We're trying to build biosensors for carbon monoxide by genetically engineering microbes that will turn different colors when they're exposed to carbon monoxide, and then set up experimental systems so we can understand, you know, which class of microbes and what chemical environment are other microbes producing CO, and then go back to the field again and study it. So it's an iterative process that I'm not sure that I don't know enough to know if the natural system is at all constant. But I'm hoping to develop the tools to test that. And I would guess that in Doug's natural system, rarely constant.
Well, it's Mother Nature knows what to do every day. We just don't know what Mother Nature's doing. Yeah. So it's interesting. You know, there's one thing that I've learned along the way that you've all helped remind me of that, and I think we almost sort of take it for granted. You know, forgive me, I was a physics major, but not all the world can be explained by physics or a physicist, and not all the world can be explained by a chemist. And I think we're really learning a lot, particularly with environmental problems, that it's really the integration of the disciplines. I cannot tell you how many moments I've had when I'm describing something, and a colleague has said, duh, you didn't know this? And suddenly the leaps and bounds of learning is when we share across the disciplines. Who would ever thought that anything about greenhouse gases would be really a big thing for Indy 500 racers, you know? And yet it is. So that's always just amazing me of how we can be so widely different in our disciplines, yet if you put us in a room for a while, we're going to find out, you know, the 6 degrees of freedom. We're all connected. It's pretty interesting.
Well, we have time just for one last question, and we'll keep our answers kind of brief.
Sure. I get a microphone now. I work with youngsters who are sort of interested in the sciences. And, you know, when you talk about, oh, bears or race cars or going half-mile underground, it's a really great way to get them excited about science. But how do you give advice to them about bridging that gap between go take your AP biology classes and go to college and major in the sciences, and then and now you end up in the Russian peninsula hiding from bears, you know? How do you bridge that gap?
That's a great question, right, because I'm sure all of you put in many, many hours in windowless rooms before you got to go out and do the really exciting stuff, right?
Oh, of course. I think the most, you're really getting to the heart of education. There's probably some more in the audience than us that can answer that. But I will tell you that for me, I remember this chemistry teacher I had, Mr. Moresco, back in high school. And it was just, this guy was really cool. You know, he was a chemistry guy. And all this equations and stuff, just overwhelming. And we were memorizing stuff, taking quizzes, but it didn't really help. I didn't really understand what I was learning. This guy said, you know, let's have some fun. And he gave us an experiment. He wanted to understand which is more efficient back in those days, the original Volkswagen Beetle or a hummingbird. And so, you know, we found out that a hummingbird could fly 600 miles on an ounce of hummingbird fat. We got a calorimeter. We found out how many calories, and we got gasoline, and we did that. And we bought the body mass of a car and so forth, and we found out that a Volkswagen Beetle is actually 30 times more efficient. But the cool part was that I've learned in life is that if you can't give them something fun to solve, they don't understand how to use the tools they're learning. So you have to put it in context.
I have an add-on to that. Because I did this for a long time. I found that it's one thing to do outreach and go into a classroom and say, here as a scientist, and these are the fun things I do. But what you realize when you're there is that those kids' teachers are there every day. And the most important thing that you can do is to help excite their teachers so that that comes across every day. And we've had some programs here at FERMILAB, and I've had the pleasure of working on them. And you know, you bring high school teachers in and you put them in a research environment. You bring elementary school teachers in and you teach them how to do little experiments, how to make experiments fun, how to integrate. I'm a real firm believer that the education should be integrated. You know, you don't just teach them math and then close your books and now we'll do science. You integrate it together, and so they see it, how it's in their real world. But the point is that we're not in the classroom every day. So we can only convey our excitement occasionally, and we can do it by targeting the teacher who can bring that back in every day. So that's, you know, that's the mission that I think we should really work a lot harder on. Because I've run into all kinds of teachers, and their hearts are always in the right place, but sometimes they'll say, I don't have the background, I don't know how to teach that. And so programs that really outreach to the elementary and the high school teacher, I think, is the answer to get the kids excited.
Yeah, thank you. Well, I think our time is winding down, so we're going to have to leave it there. I want to invite Director Ardone to return for some closing remarks.
Well, I want to thank you, Gabriel, and all the panelists. It was really a fascinating evening, and all of you for coming and making it interesting, good questions. And invite you to stay and share some drinks and have some conversation following this among yourselves and also with the panelists. Thank you very much.
Thank you, Gabriel.